And we're live. Welcome everybody. It's day 9 of Adventure Code. It's the 9th of December. And we've had 8 days. Yesterday it wasn't too bad, but it was a bit hard. 7 was also a bit hard. So hopefully today, also Friday, it's not going to be too bad. But I'm excited to see what Eric has in store for us yet again today. Let's just go to my environment, have all my files, yep. Okay, and I'm ready to begin. So, we'll see what today's like. Hopefully it's not too bad, and I'll see you after the time lapse. Okay, that's part 1 done. I think that took me a bit longer than I wanted, just because I missed that really basic error about that full up. I'll tell you about that later. I'm pretty happy with that. That's really fun. I don't know why. I just found that pretty fun. But yeah, I'll move on to part 2, and I'll see you after the time lapse. Right, that's part 2 done. Yeah, another silly mistake in there. But yeah, I managed to do that pretty well, I think. Anyway, yeah, that was a great day. Yeah, really random, really random day, but I like that. Right, so let's go to the day. Day 9, rope bridge. This rope bridge creaks as you walk along it. You're unsure how old it is or whether it can even support your weight. It seems to support the elves just fine though. The bridge spans a gorge which was carved out by a massive river far below you. You step carefully. As you do, the rope stretches and twists. You decide to distract yourself by modeling rope physics. Maybe you can even figure out where not to step. Okay, so you're distracting yourself as an elf or as a human as you walk across the rope bridge. And the way you're doing that is by modeling the physics of the rope. Okay, consider a rope with a knot at each end. These knots mark the head and the tail of the rope. If the head moves far enough away from the tail is pulled towards the head. Due to nebulous reasoning involving plank lengths. Plank length. Oops. Plank length. Okay, don't understand that just yet. Anyway, you should be able to model the positions of the knots on a two-dimensional grid. Yes, grids. Then by following a hypothetical series of motions, your puzzle input for the head, you can determine how the tail will move. Due to the affirmation plank length, the ropes must be quite short. In fact, the head and tail must always be touching, diagonally adjacent and even overlapping both counter touching. If the head is ever 2 steps directly up, down, left or right from the tail must also move 1 step in that direction, so it remains close enough. Otherwise, if the head and tail aren't touching and aren't in the same row or column, the tail always moves 1 step diagonally to keep up. You just need to work out where the tail goes as the head follows a series of motions, assuming the head and tail both start in the same position, overlapping. For example, blah blah blah, very long example, it's irritating to scroll through. Eric. Anyway, after simulating the rope, you can count up all of the positions the tail visited at least once. Simulate your complete hypothetical series of motions. How many positions does the tail of the rope visit at least once? Right, yeah, so quickly reading that, and I guess, it's pretty obvious to see that all of this is just story junk, so I just skipped that when I was reading it. I skim read that, and then, yeah, I kind of skim read the rest, to be honest. But I think like the 2 key bits are these 2, this line and this line, because they essentially tell you how you're going to model it. Like, I was so confused when I initially read it. I went back to this problem, I saw that, and I just thought it was super easy from that point onwards, because Eric literally tells you what to do. It's a matter of trying to do the maths fast enough, which I did. I just didn't do very good maths. It wasn't very nice. Definitely a fast way to do this, but I wasn't too good on that. Right, so just opening the file. This is my solution, opening the file. Visitor set, this is just keep track of all the coordinates that the tail is visited. QW, right, so Q is the head, W is the tail. Sorry for the names, they're easy to type, and then right next to each other on a keyboard, so I'm using them. Right, and then you obviously just need to add the first place the tail has been to your set. And then because sets can't have lists inside them, you have to have immutable objects, just tuple the list. And you'll see I've done that down below here for everything else. Right, so now I'm going through every line or every instruction in the input. I'm just listing it so that A is the direction, and B is the length, and like getting it into B. Right, now this is the bit where I messed up. So what I initially did is I didn't have this for loop, like at the top I didn't have that. So I was just moving the head, like a set number of things, a set number of places, and then moving the tail. Obviously that really doesn't work. What you're meant to do is you're meant to move the head, then the tail, head, then tail, like I guess a real rope. I probably should have thought of that, to be honest. Yeah, I guess it kind of is my fault for missing that with common sense. But yeah, what I was doing is I was just moving the head all of the ways it was meant, like the entire way, like the entire 10 steps for example, and then moving the tail. But obviously since it's one rope, you move the head, then the tail, then head, then the tail. And that's what this for loop does. It just goes through the same process as many times as you're meant to move forward, or left, or right, or down. Right, and then based on the direction you're moving in, you just change the coordinate of Q. Right, so what Q is the coordinate of the head, and W is the coordinate of the tail, and they both just start at the origin. There's just a relative coordinate system. You can make the coordinate whatever you want. Just starting at 0, 0 is just simple. Right, so you're changing the coordinate of the head based on what your move instruction said. Right, and then here, line 28, what this does is it checks, essentially, as I said earlier in the question, it literally tells you the exact 2 cases you're meant to check for. Like, it's just a matter of you having to program it. And then two cases you might check for is this or this. So I mean, this is probably easy to check first, just because this is also kind of true for my check of this. So like if I check this first, then this will turn true for both this scenario and this scenario at the bottom. Right, sorry about that, my Firefox crashed again. Clearly something going on again. But anyway, what I was saying is that if you put the condition for this first, at least where I did it, then it would return true for both this scenario and this scenario. Even though they're different scenarios, they still return true. So by putting this case first, you ensure that this is accounted for, and then you check for this one, and then accounts for that one. Right, so so what this line does is it checks for this bottom case, and the way it does that is by saying it essentially takes the Manhattan distance between the head and the tail. So the Manhattan distance is the total x delta plus the total y delta. So essentially, for example, would be this one over here. So the difference in x values between the head and the tail is 1. The difference between y values is 2. So the Manhattan distance would be 1 plus 2, which is 3. And you know, if you're in this scenario, you're always going to be a Manhattan distance of 3 away, because you're 2 in one direction and 1 in the other. And so that means I'll just calculate the Manhattan distance here. And if it's equal to 3, then I know I'm in that scenario. And I just absolute values here, like make them, because Manhattan distance is absolute values, right? It's the delta between the coordinates. And so obviously if you have a negative coordinate, that doesn't matter, it's just like the absolute delta, the difference between them. Not really the delta, just like the difference. But yeah, this just calculates the difference between x and y. So now I've established I'm in that scenario in these lines. What I do here is, what do I do? Yeah, I check which direction I've moved in 2 spaces. So that's what the first if statement does here. It checks if I've moved 2 spaces left. So like, is the head 2 spaces to the left of where my tail is? And if it is, you just want to obviously move your tail in that direction. And I mean, what Eric stated here is that you move to one of the 4 corners that you can move to, right? So that means your head's going to move your tail's going to move each of its coordinates by 1, because that's what going 1 or minus 1, because that's what going into a corner means. So I move this direction, and then that's my x coordinate. So what about my y coordinate? I need to move that 1 in some direction. So it's either 1 or minus 1. And the way I do that is I just calculate like where is the head relative to the tail. That's what this does. And then it just chucks that answer on. So if it's down, then the answer will be negative to that, because you have a small number minus a big number. If it's above the tail, then head minus the tail is going to be positive. So tail's going to move upwards. And yeah, I know I can do this because I've already checked for the case of the coordinate where it's 2 apart, right? Because in a scenario, only one of the x or y coordinate has a delta of 2, and the other coordinate always has a delta of 1. That's just the nature of the question. So since I've already checked for the coordinate having a delta of 2, I know that the other coordinate will have a delta of 1. So since like the x coordinate here, a delta of 2, this time I'm referring to the y coordinate, and I know that's going to have a delta of 1, so I know this is going to move in the right direction. And then yeah, I just add the new coordinate of my tail to my visited set. And yeah, I just repeat that block of code several times for each of the four directions you could have moved 2 blocks in. You could have moved 2 blocks up, left, right, or down, relative to the tail. And so you just kind of for all the scenarios, just changing a couple of these numbers as well. Yeah, that's pretty much it. And then my second if bit is checking for this. So if it's 2 away in any direction, that's pretty easy actually. You just check if either the x coordinate is greater than 1 or the y coordinate is greater than 1. Because if either of them are greater than 1, then you know it's like you know that the head is going to not be in the 8 adjacent cells to the tail, right? Because for example, let's look at this picture, like this 3x3 grid. All of these dots are within one x and y of h, right? So That means all of the dots right outside that or beyond are going to be greater than 1 in either X or Y, or even both. So what I'm doing is I'm checking if it's not in the immediate 8 adjacent cells, because if it is, then you don't do anything. That's what Eric said. But if it isn't, then you need to move in that direction. So I check if the Y coordinate delta is greater than 1, or the X coordinate delta is greater than 1. And then again, I just look for which direction I've actually moved in. Just with these if statements. And then depending on which direction I've moved in, I move the tail to correspond to the direction the head's moved in. So many different ways to do this. This is the first that pops into my mind, and since it's the first, it's probably the fastest to code. Obviously, there are definitely ways to improve this and optimize it and make it more efficient. This is the first method that popped into my head, so that's what I wrote. And ultimately, it's not that difficult to just copy paste the same thing. So I chose this. I mean, it's the same here. Like when I add the tuple to the visited set, the coordinate to the visited set, like I add this every time. Like I might as well just add it right at the end, right here. I didn't do that just because first thing I thought was to chuck it in here. And since I'm copying and pasting the same thing so many times, there's really no like benefit, I guess, to doing anything else. Right, so now I've kind of all of that. Yeah, I'm basically just simulating through the entire thing. I've done that, and I just print out the number of unique coordinates I've visited just by printing len v. Right, so that was part 1 done. Really nice and fun. And let's move on to, where is it? Man, these scrolls are so long. Let's see. Part 2. A rope snaps. Who could have guessed? Suddenly, the rope is getting a lot closer than you remember. The bridge is still there, but some of the ropes that broke are now whipping towards you as you fall through the air. The ropes are moving too quickly to grab, but you only have a few seconds to choose how to arch your body to avoid being hit. Fortunately, your simulation can be extended to support longer ropes. Rather than 2 knots, you must now simulate a rope consisting of 10 knots. 1 knot is still ahead of the rope and moves according to the series of motions. Each knot further down the rope follows the knot in front of it using the same rules as before. Using the same series of motions as the previous example, with the knots marked H blah blah blah. Here's an example. And more example. Ooh, be careful. More types of motion are possible than before. Yeah, it's in bold because, and I guess this is where my trick. You told me to do a trick. I'll talk about that later. So you might want to visually compare your simulated ropes to the one above. Yeah, I think that's just a waste of time. Like that takes a lot of time, so I'm not going to do that. More examples. Simulate your complete series of motions on a larger rope with 10 knots. How many positions does the tail of the rope visit at least once? Again, so like the question statement is the same, but you just have a longer rope, and therefore you have like a longer rope to simulate. And so like this key bit I was just talked about, the however bit. You probably saw me in the time lapse. I tried to just chop off the first 10 movements. Obviously, firstly, my logic for doing that was wrong, but we ignore that. Let's assume I successfully chopped off the first 10 movements. That didn't work, and that wouldn't work because, again, he says the different types of motion are possible, right? So what that essentially means is that you can be put in a scenario like this, for example. Let's find a better example. Like I can't find one, but you can be put in a scenario where the majority of the rope moves, but the tail doesn't. So even if the head moves and all of the other knots do, they could have moved in such a way that the tail is still adjacent to the knot before it, right? So the tail does not move directly according to how the head moves. It's not relative to how the head moves, because each knot is relative to the knot before it. So the second knot is relative to the first knot, which is the head, and that means that because you have like that sort of relative chain going down, by the time you get to the 10th knot, the tail, it may not be moving relative to the first knot. It's definitely moving relative to the 9th knot, but maybe not the 8th or 7th or 6th or the 1st. And the way we know that is because of these rules. If it's two-way, you move. If it's two-way and one in the other direction, you move. But what if it's moved from being adjacent, like here, for example, to being diagonal? You don't move that knot. Even though the knot above you has moved, even though T here has moved to the right, for example, H remains in the same place. And that's the issue. That's why you cannot just use the position of the head to determine the position of knot 10. It may take a while for you to like really sink in that logic, but that's just true. That's just a fact. Right, so my code. Here, I'm just importing deep copy because lists are mutable, right? So they change. and I don't want any random issues with list changing. I don't think I actually needed to do this. It's just when I'm trying to go for speed and I'm not perfectly sure on something, I'm going to go down the route which makes sure I can't make an error. And just make sure I can't make an error. I'm pretty sure like the copy command would be better, but I don't actually know if it's .copy or like .copy X or something. I don't know. I didn't know what the command was, but I knew the command for deep copy, so I just used that. Right, so what I do here is, before I had Q and W as my head and tail, but here I have 10 knots. I now just essentially have a list called WW, and that's just a list of the coordinates of all of my 10 knots. You can ignore QQ here. I didn't end up actually using it, so you can just ignore that. So WW, you can see all the knots start in the same position, the same coordinates, because that's just how they start. And of course the head therefore in this scenario would be index 0 of WW, which is just the head, the first knot, and then the last knot would be index 9, the 10th knot, and that'll be the tail. So similar code to before. Really the only change is this bit, because instead of just simulating the one knot just by simulating W relative to Q, you have to simulate all 10 knots, or I guess all 9 knots, because you're told how the head moves, so you have to simulate the next 9 knots, because you're told how the first one moves. So I just have this loop to simulate, repeat the exact same code as before, and simulate those other 9 knots. And here I just grab a Q now doesn't really represent the head, right? It represents the previous knot, because you're always moving relative to the previous knot. So that's why I just have the -1 here for the index, and I start at index 1. Hopefully that made sense. So Q, the list here is always the knot in front of W, right? Because the index is -1. And I mean, if Q is the first item in the WW list, the first knot, then you have to move that relative to the instructions. So that's what I've just written here. If the current index is the first one, right? So if triple I is 1, then you know Q is going to be this. So it's going to be 0. It's going to be the first element of the WW list. So Q is going to be the head, right? So this checks if Q is the head. And if it is the head, then you just simulate the moves. And if it isn't the head, then you just do the rest. I mean, you do the rest anyway, because the rest is all relative to the one to the knob in front of it. And this code I think remains the same. Only difference is instead of adding the coordinates to the visited tuple after every if statement, I have to delete those and only add it if you're on the tail. So again, because in reality we're only interested in the head and the tail, but to discover where the tail is, you have to consider all of the other 8 knots, right? So like this just runs for all the other 8 knots, but in reality we really care about the head. That's what that code does. And for the bit where we care about the tail, that's what that line does. It checks, am I on the tail? Is triple I equal to 9? Am I on the 10th knot? If I am, then this is a relevant knot. It's the tail. So that's what you need to add to your visited set. And then here I'm just updating the knot positions. Again, I don't think that's actually necessary. Just peace of mind, and to ensure that's not going to be a bug, I did that. And yeah, I think that's pretty much the code. Yeah, the rest is the same. I think the key here was getting the logic right, getting the for loops in the right place and kind of storing these. It took me a bit longer than I would have hoped to figure out the logic. And I think that's kind of where I messed up. Or yeah, I think that's where I mostly messed up. No, so that's not where I messed up. That's where I lost time. Where I messed up is here, because I forgot to consider the fact that only the first knot moves relative to the input instructions. Everything else moves relative to the knot ahead of it. So that's just what I had to fix here. I didn't really consider that, which is a bit of an issue. Because I basically didn't have this line, right? So I was moving every knot relative to what the head's meant to move, essentially. And that just doesn't work, because that's not what you're meant to do. And there are so many, if you think through that logic, there are so many holes and issues. And yeah, that just didn't work. I realized that pretty quickly though, so I think I got some decent times logged in. But yeah, that was my code. Really enjoyed that day. Probably my second favorite right after day 7. That was quite nice. Simulations, logic, random stuff, so many ways to solve it. It's great. Right, and let's go on to look at my 18 stars. So let's look at the calendar. Yeah, building up slowly. I wonder what this is. I don't know what that is. Probably. Oh, that's the road bridge. Yeah. that is the rope bridge, right? Because that's the color of rope, and I guess today was a rope issue. I guess speaking of that as well, like day 8, I didn't notice this yesterday, but you know day 8 was all about building tree houses and looking ahead. Yesterday, even though day 9 was still locked, like I had this timer, just like day 10, and therefore all of these would you on the advent calendar you expect to be grayed out. A few of them weren't, and I guess that's just like Eric's Easter egg of saying, oh look at that, day 8 was building a treetop, building a tree house and looking over the trees, and therefore you can see part of the day 9 advent calendar. That's kind of cool, actually, really cool. Yeah, leaderboard. Man, you know better Ross, he's written his own programming language in Rust, I think, and he goes in that. Man, he's crazy. He's mad though. He's smart. I like him. Right. Ooh, these aren't as fast as I expected. Oh man, these are really slow actually. Although I guess part 2 is time to. Oh wait, what? Twice as long for part 2. I don't know, how do people do 6 minutes for the first person to do part 2? How do people do these? Like, obviously these people are all pretty much smarter than me. So they probably thought of some really random, complicated, weird method in whatever random programming language they use. Which probably meant they were slow. But yeah, that's good. I mean, that's not good, I guess, because they are quite slow. But I'm really interested. I want to see what solutions they put up. I'll look at that later anyway. Look at my private leaderboard. Man, he's building up a lead, yeah. And Danish is also building up a lead off Have Enough. Yeah, I think these 3 will roughly remain in the same positions, but separate a little, assuming they all wake up on time, which they won't. I'm calling that now. Right. Yeah. Makes sense. So how fast was Anonymous? Wait, that's leaderboard position. That is leaderboard position. Damn, 132. He racked up tons of points. What was that? It's like 80th for part 1? I don't know. And that would be really fast. That would be like 30th for part 2. Probably more because he got more points than that. Yeah. Wow, well done to Anonymous. That delta time. Oh, that's nuts. How on earth did he code part 1? Or did he just think of the part 2 logic so fast? I don't know. Right, let's look at these delta times. Yeah, I haven't had to 11 minutes, probably close to 10, but I had that logic error. It took too long to realise. But yeah. These are some good times. Yeah, I want to see how these people coded that program, because surely they coded it in such a way that meant it was better. Right? Or they just thought of the logic really fast, because I guess if I did make my bug code, it would be quicker. But not this quick, surely. I don't know. I really want to see their programs, yeah. I want to see people's programs for today, because they all seem really different and interesting. But anyway, yeah, that's it for today. Day 9 of AoC. I really liked that day. That was solid. Interesting puzzles, good simulations, love the logic, love the maths. I love coordinates. Coordinates are my best friend. Yes. Anyway, yeah, I think that's it for day 9. Tomorrow's the weekend. Get to double digits. I'm not expecting anything easy. I'm expecting something really tough, because today wasn't even that bad. So, Eric, please be relatively kind. But yeah, hopefully you guys managed to do day 9. Hopefully you found that interesting. And I'll see you tomorrow for day 10.